Hi, hello, I'm Yoshiki Oshima from the Croquet Corporation, and I'd like to present a system called Croquet Microverse, where you can build stuff. It's a 3D environment where you can build stuff from within. And the main topic is a 3D environment, but I am using a tool that's a 2D environment, and that's actually collaborative. And Tony Mattis there he's not affiliated with our group, but he's a friend who is going to help my presentation. And so what we are trying to do is to create a multi-user 3D environment where people can go in and collaboratively create things from within the system, from within the world. And so there are many challenges, but I listed 3 of them. So first of all, making a collaborative system is hard. The programmer or developer like us have to maintain the consistent state across the distributed computer. And the 3D programming is hard. So you need to deal with those numbers in your text and sort of imagine where your object is and which way it's going to move and run it and see if it works or not. If you have to do that, yeah, that's really error-prone and time-consuming. And of course, making a live programming system is hard. If it's not hard, we are not here. So code changes have to be handled properly, especially in this distributed system. If somebody changes code, it has to be properly propagated, and all state has to be maintained, and it should keep the consistent state. But I forgot to mention, but important thing is that if we have a live programming system for 3D environment, and you can incrementally and simultaneously, actually, there are multiple people in the space, and typically when you have many people in the space, there are many different sub-applications in the world. And those users want to change different parts. And if your system requires that the system has to be rebooted only when one user makes one line of change, that's not going to fly. So being a live programming environment is very important. And so there are challenges, but we have a good solution to use, basically. That's the system called Croquet. So if we build a 3D environment on top of Croquet and then design that system to be live programmable, we can achieve this goal. So so let's talk about what is Croquet. So Croquet is a platform to make collaborative applications. And we actually call it an operating system for collaboration. And it sounds like it's just a network infrastructure and the library for your browser. So what is this about the operating system thing? But Weizmann once upon a time, a wise man said that an operating system is a software platform that manages space and time. And okay, so yeah, that sounds nice. And from that viewpoint, Croquet does manage space and time, distributed system and time part. It has an explicit notion of time. So from that viewpoint, we say Croquet is an OS. So it's a library to make collaboration system. So it is fully web-based. So you don't have to install an app. You just go to a website and run this application. That's how this is running. And then I was going to make some facetious comment about this network first thing, but because Peter gave a great talk and it has serious attention. So Croquet is network first. If you want to interact with other people, you have to be online. And this is like a 3D environment, so it's real time. But it's just by default. But it doesn't have to be network fast. Actually, I'm going to talk about later means that this server can be running on your local computer, and it's going to be a local development environment also. So we are not we are friends. We are not fighting with each other. And the important thing about Croquet is that you don't have to write any backend code. You just write .js and .html for browsers, and you load it, and it becomes collaborative. So I'm going to show a little demo. So in this environment, for example, I can resize this window. But Tony, can you move this sticky node? And he can actually move around, and while I am resizing. And you cannot do this actually in systems like Miro or Google Jamboard if you tried. You do this and you don't see the effect from the other person. You wait. Once the person release the mouse and wait 2 seconds and your screen updates. And that is not the real-time collaboration we are talking about. It has to be really as if you put your hand into computer and do stuff together. That's what we are trying to do. And then, you can go to, for example, the documentation site and how to make this kind of stuff. I cannot go into too much detail of this, but it's suffice to say that we don't have a server that computes the application state. Our server is called, for marketing reasons, called the edge reflector, but it doesn't compute. It just gets event from clients and reflect the event back to all participants. And all participants compute the new state based on the event. So our system here, virtual computer part, guarantee that when they start from the same state and the same sequence of events arrive, it guarantees that they are in the same state. And it's running on local computer, and the view, which is separate from the virtual computer, that just renders stuff onto the screen without going to the network. So that's how this is working. And as I said, the reflector here is based by default on the internet, but it can be on your local computer or just a Wi-Fi router here or such. So you get pretty good response time. And in this case, we are using a reflector in Australia, I think. But this is still working pretty well, even though we are on an island, which is far away from any known civilization, except the Middle Earth, of course. So it's working pretty well. And the programming model side, as I said, the most important concept here is that the model and view separation. And then the model means that this part here has to be bit identical and deterministic and replicatable across the computer. So that's the important part. That's how we ensure that just receiving events is enough to get the distributed computation. But on the other hand, view can do anything the browser lets you do. So you can make sound, you can make 3D graphics, you can do all sorts of stuff. So that's how this system is working. And this is one of the little application. So this is actually my personal website. I'm getting nervous. But let's say I pop out the QR code and I scan it. And so this one, I can scroll, and Tony can actually scroll the thing. His computer, and this is, then here it's scrolling, and I can scroll here. So it's really, this scroll position is synchronized across those computers. And I didn't install an app, I just scanned QR code, and it's like this. But of course, simple applications is easy, but what we want to make is a collaborative programming system that's a little bit more involving. So important thing is that because participants are making changes to code, and we want to clean the install and uninstall those changed program. So in that sense, our code has to be data. It has to be replicatable and transmittable over the network. And in JavaScript, that's a little bit interesting, so to speak, because you cannot serialize closures. You cannot look into closures. And so there are some restrictions we have to impose, like you cannot store functions in the model's property or such. And you cannot use non-deterministic state like date now or such. But if you just avoid a few things, and also forgot about the random number generator, for example. We patch the random number generator. So those replicated virtual machines produce the same random number, if we call it. So those little things make it replicatable. So that's something you have to do. And the main contribution here is the design of this attachable and detachable object extension mechanism we call behaviors now. And inspired by long history of class extension mechanisms and object extension mechanisms like pi, expanders, mixing traits, and kind of stuff. But it's designed for the Croquet system. And I want to show a few examples. And it's basically a set of methods. It's like small talks, traits, and it's a set of methods that expect to use the base class features. So if you are writing a model extension, let's say you want to have an object turning, so that says, let's say step here. So as long as it's turning, it rotates by a little bit here, and then there's an explicit notion of time in the programming model. So this one says in 100 millisecond logical time after, just invoke yourself one more time. So that makes it rotate in the space, and you can write those event handlers and stuff. And that was the model side. So that's the replicatable part. So rotation, turning, those properties are serialized, can be serialized. But in the view side, you can do anything. For example, 3JS uses the WebGL, and you can render 3D graphics. So we can instantiate geometry and material and create a framework where we can manage the 3D graphics. And this one basically says highlight when you hover mouse, and the unhighlight when you unhover the object and stuff. So you basically write this kind of code here, and that's how you program the 3D environment. So let's go to the demo here. And so this is really just a URL, and this is just an iframe inside, but I can load it. Oh, actually, so I forgot to get into the presentation mode altogether, but if you are watching, I forgot to do it, Tony's computer there. Yeah, it's actually, he's seeing what I am seeing here. So this is basically the web page, and I can do this again if just do it. So this is a 3D world, and there are many interesting objects in this world. But let's show a few things. And one thing is that this door, I cannot go through, but I actually take Tony with me here together. So if you look at his screen, it's moving too. Also, there's a drone flying, interesting, and it's going in circle because this program here, it's specifying that similar to the last example, step here says that basically 20 milliseconds in the future, schedule itself, something is going on. But besides scheduling yourself, basically rotate by a little bit and forward by a little bit. So it's like a turtle graphics, and that's why it's going in circle. And this toggle thing means if I click on it, it stops. But here, it sort of doubles as a no-code like environment. So I can open this property sheet and put it a little bit aside, and I can say duplicate. So this copy has the same behavior attached, and this initialization part says, this I start rotating. So they are moving this. But this program is actually, it's like a Google Docs. You can edit. So they are going this way because it says forward by 0.03, but I can edit this to minus 0.03 and hit accept, and they go the backward. And you see, same thing is happening on Tony's computer too. And I can change, like rotate by values and stuff. But so you can change the behaviors in the world from within. So we thought this is pretty cool. But one of our ex-colleagues looked at this and said, there are professional programmers out there, and they have their favorite editors, and they are not going to program a system with this great-looking rudimentary text editor. And I thought, okay, he has a point. So we thought we should make that work too. Here is a different parts of the factory, and something is happening here. I should close. Oh no. So if I open it, there's some engineers have too much free time, so they set up some physical contraption here, and this is actually the physics simulation running, and the same thing is happening on Tony's computer. And if Tony tap the stopped cube, same thing happens. This guy, I'm going to stop it. So but this kind of complicated program was written in a text editor. So let me actually share my screen here. And let's say, where did it go? So there's a great text editor called Emacs. And then this program here basically describes, I need to do connect here. So if I say connect, this browser session connects to watch server running on my computer. So if I say, it's producing like random colored objects, so random color. First of all, the display method, like the other things, basically 500 milliseconds in the future, it calls itself, and inside it creates a new object. And from that method, this random color method is called. So this one called math random, and compute HSB and convert that to RGB. But let's say Tony is my designer, and he says, no, I don't like those random colors. I just want to have red one. Then I can say, okay. Then let's just make red things. And I saved the file, and then my watch server notices it, injects the code into the system, and on his computer and my computer, now it's producing all red. And still it's perfectly replicated. All objects at the same position. But not only this kind of the parameter tuning. How much time do I have? I can really do sort of the real program. So instead, in addition to spheres and cubes, I want to have cylinders. So because of the model view separation, there are a few places to edit. The first is the model side. So when somebody asks the model to make a cylinder-shaped object, I create this physics collider description that is cylinder. And I saved it, but nothing happened yet. But in the view side, let's say if somebody asks to make a cylinder shape, I make the 3JS cylinder geometry, and I save the file, and still nothing happens because the spray here has a random variable called dice, and here it says when the value is less than 4, make a cube. But let's say if the value is less than 0.7, let's make a cylinder, and I am going to save it. And now once in a while, the cylinder is created. So that same thing is happening there, same thing is happening here. So this is basically, because we are making this as a product, it has to work for people, and it's not just a hand waving. Okay, oh, good timing. Hand waving like demo. This is how we develop many of those things, and our customers use this to develop the collaborative 3D environment. So that's basically the conclusion. Yeah, so that's what we made, but there are many future work remain, and I talked about the explicit notion of time, but we don't have stuff like back-in time debugging, and the debugger. I can actually use the Chrome's regular development tool to debug it, but it's not shared. So that shared inward debugging is something we want to have, for example. So yeah, that's it. Thank you very much.